Hello everyone, I am A. Victoria Anand Mary, Assistant Professor, PG and Research Department of Computer Science, St. Joseph College of Arts and Science, Autonomous Kadalur. In this presentation, we will see the definition of algorithm, difference between algorithm and a program, criteria for an algorithm, steps for writing an algorithm, performance analysis, divide and conquer method. The syllabus for Unit 1 is divide and conquer, introduction to algorithm, complexity analysis, divide and conquer, Strasson's matrix multiplication, quick sort, merge sort, binary search, finding maximum and minimum. This is the prescribed textbook. We'll start with the definition of an algorithm. An algorithm is a list of steps for solving a problem that transforms the input into its corresponding output. That is, using these steps, we are going to convert the input into output. What is the difference between algorithm and a program? An algorithm is finite. That is, we can have the steps are countable. We can count the number of steps that is present in an algorithm. But the program is not finite. That is, in a program we'll be having a recursive function, so it is not possible for us to count the number of steps. Algorithm is written using natural language or algorithmic language, that is simple English terms. The algorithm will be written, while the program which is written, it will be a specific, it will be using a specific programming language like Java, C++. What is the criteria of an algorithm? All algorithms should satisfy the following criteria, that is input. It should be having 0 or more quantities which are externally supplied. Output, at least one quantified quantity is produced. It should be having at least one output. Definiteness, each instruction should be clear and unambiguous. That is, it should not be confusing one, it should be clear. Finiteness, if we trace out the instruction of an algorithm, then for all cases the algorithm terminates after a finite number of steps. That is, it should be as we already saw, algorithm is a finite, so that it should be having a finite number of steps. Effectiveness, every instruction must be very basic so that it can be carried out. In principle, by a person using only pencil or pen, it is not enough that each operations be defined as in criteria 3, that is definiteness. It also must be feasible. It should be feasible with other terms. Steps for writing an algorithm. An algorithm consists of two parts. The first part is a paragraph which tells the purpose of the algorithm, which identifies the variable that occurs in an algorithm and a list of input data. That is, it will be having the overall description of the algorithm. And whereas in the second part, it consists of list of steps. Here the original steps will be employed, that is to be executed. This is the simplest algorithm which helps us to add two numbers. That is, we'll start with step 1. Step 2 will be declaring 3 numbers A, B and C, and step 3 define values for A and B so that we can add it, and the added value of add values of A and B, which is carried out in step 4, and in step 5 we are going to store the value that is obtained in step 4 to the variable C, and finally we are going to print the C value, and finally we'll stop the execution. This is the simplest algorithm for adding two values and printing it. Algorithm analysis. Efficiency of an algorithm can be analyzed at two different stages, that is before implementation and after implementation. They are the following. Priori analysis. This is a theoretical analysis of an algorithm. Efficiency of an algorithm is measured by assuming that all other factors, for example processor speed, are constant and have no effect on the implementation. Okay, before writing an algorithm we are going to analyze. Okay, posterior analysis. This is an empirical analysis of an algorithm. The selected algorithm is implemented using the programming language This is then executed on target computer machine. In this analysis, actual statistics like running time and space required are collected, are analyzed. Performance analysis. There are many criteria upon which we can judge an algorithm. We can judge in terms of, and we can check whether these questions are satisfied. First one is, does it do what we want it to do? That is the original objective. Is it satisfied with this algorithm? Does it work correctly according to the original specification of the task? Is there documentation that describe how to use it and how it works? Are procedure created in such a way that they perform logical subfunctions? Is the code readable? And in these terms, after asking all these questions, we can analyze the performance of an algorithm. Performance analysis or complexity of an algorithm. We are going to check how good is an algorithm in terms of time complexity and space complexity. Time complexity of an algorithm quantifies the amount of time taken by an algorithm to run as a program or as a function of length of the input. That is total time that it requires. Space complexity of an algorithm quantifies the amount of space or memory taken by an algorithm to run as a function of the length of the input. Time complexity of an algorithm depends upon the compile time and run time. Compile time, it is the time required to convert the source code into its object code. It is independent of the instant characteristics. Runtime, it is the execution time of the program. Space complexity of an algorithm is calculated by the sum of the following, that is fixed part and variable part. Fixed part, it is independent of the characteristics of the input and output. This part include instruction space for simple variable and fixed size variables. Variable part consists of space needed by the component variable whose size is dependent on the particular problem instant that is being solved, and space needed by the reference variable and recursion stack space that is required. In this example, we can see algorithm ABC has a parameter ABC, and it is doing some calculation purpose, and we are going to have the fixed part and variable part type of analysis in this algorithm. Next is divide and conquer method. General method. Divide, the problem which has been given is going to be divided into number of subproblems, and in conquer we are going to solve those subproblems, and finally we are going to combine all those solved subproblems to achieve a single output. As illustrated in the diagram, we can see problem is divided into two subproblems, and conquer is going to solve those subproblems, and finally we are going to solve, or we are going to combine those subproblems to achieve or to obtain a single final output. Control abstraction of divide and conquer method. A control abstraction is a procedure whose flow of control is clear but whose primary operations are specified by other procedures whose precise meaning are left undefined. Control abstraction. Okay, the control abstraction for divide and conquer technique is divide and conquer of P, where P is a problem to be solved. We can see this algorithm that is employed. In this algorithm, we can see that we are going to check, we are having a problem P, and we are going to check whether the problem is small. If condition is used to check whether the problem is solved. If it is small, we are going to return the particular some calculation, and we will be returning that. Otherwise, the problem P is going to be divided into smaller instances, P1, P2, P3, likewise it will be going on, and we will apply divide and conquer to each of these subproblems. It is a recursive function. We are going to, if P is going to be divided into P1, P2, P3 likewise, and again we are going to check with P1 whether this particular P1 is small or not. If it is not, again we are going to divide that particular P1. Likewise, the process will be continuing until we will satisfied with small p. until we achieve a smaller part of problem that has to be solved. And finally, we'll be combining all those results which have been achieved from those subproblems and to obtain a final output. Small p is a Boolean value, that is, it will be true or false, which determine whether the input size is smaller enough so that answer can be computed without splitting. If this is so, function s is invoked, otherwise the problem p is divided into smaller subproblems. These subproblems p1, p2, pk are solved by recursive function. If the size of two subproblems are approximately equal, then the computed time of divide and conquer is t of n is equal to g of n when it is small. Otherwise, we are going to split that into 2t inside the bracket n by 2 plus f of n, where t of n is the time for divide and conquer on n inputs. G of n is the time to complete the answer directly for small inputs. Otherwise, f of n is the time for divide and conquer. Sjctnc matrix multiplication, it is an application of divide and conquer method where we are going to multiply two matrix. In this diagram, we can see A and B are two matrix, 2 cross 2 matrix, and we are going to do multiplication process, and we are going to have a final output, that is C. It will be again a 2 cross 2 matrix. Using these formulas that have been provided here, P1 to P7, where A11, A11, 11 represent first row, first column. A22 represents second row, second column. If we are provided with the values inside this matrix, and if we sort out those values according to this formulas, we can obtain the final multiplied matrix, that is C matrix. It will be again a 2 cross 2 matrix after all the calculation using these formulas. This is the best application of divide and conquer method.